Good evening, everyone. Welcome back to the Astro Imaging channel. Hope everyone's had a nice Mother's Day and Mother's Day weekend. We've got another great show for you tonight. Rumen Bogdanovski is here with us. He's back on the program to talk about recent updates to Indigo. And if you're not familiar with Indigo, it's a framework for controlling astrophotography equipment, conceptually similar to ASCOM, but Indigo is multi-platform, so it's not limited to Windows like ASCOM is. And before we get into that, though, I'll just briefly show the upcoming calendar. Get to the right screen here for that. All right, so as I said tonight, Rumen is here. Then next week we've got Brad Bush of Bush Labs, which is really kind of an interesting concept. It's basically rentals of space telescopes for amateur astrophotographers. It sounds pretty interesting. I'm looking forward to hearing more about that next week. The following week, no show. It's Memorial Day weekend, so we'll be off for that. Then on June 1st, we've got Scott Roberts from Explore Scientific. And then Luca Bartek, the space koala, will be with us, and she's going to talk about a pipeline builder script in PixInsight, which sounds pretty cool. And then, as you can see from there, we do have a number of open dates. So, as always, we'd certainly love to have you on the show. If there's something that you'd like to talk about, drop us a note. And we've talked about it before. We've certainly done a lot of shows, a lot of topics, but sometimes folks think, oh, well, everything's been covered on the Astro Imaging channel. But the reality is, of course, there's always tons of stuff that we've never talked about. But even topics that we have had on the show 2 years ago, there's always updates. Tonight's a perfect example. We've had Rumen on the show before, but he's been working on Indigo, and there's all kinds of new things over the last couple of years. So don't let that stand in your way. If you've got something that you'd be interested in presenting, we would love to have you. So let me stop presenting. All right, and so that then brings us to tonight's presentation by Rumen Bogdanovski about the updates to Indigo. And as I mentioned, Rumen was on the show a couple of years ago and introduced Indigo at that time. And since then, he's been working on some additional features and other developments. So he can tell us all about what's been going on with Indigo since the last time he was here. So Rumen, if you're ready, we're ready for you. So I'll let you take over.
Hi, everyone. Well, today I'm going to show you a little presentation of what is Indigo, just like a reminder of what is Indigo for the ones that haven't seen the show. And then I'll explain what are the new things, and I'll make a quick demo of them with the simulators, of course. But anyway, so I'll start with the presentation. Okay, let me just share my screen. Okay, then. So do you see my screen now?
Looks good.
Yes, we do.
Okay. So Indigo framework, what's new since 2023? Actually, my last appearance was 2023, so I'm going to explain what happened since then. First part is, what is Indigo? Well, Indigo is a software framework for controlling astronomical equipment via software communication bus. It basically operates on properties. Every device has its specific properties, which can be mandatory or optional. And mandatories can be viewed as variables like holding the screen, the frame size, like width and height, and things like that, and can be viewed as routines like exposures, like start exposure with 1 second, 10 exposures with 1 second exposure, and it will tell Indigo to do this operation for us. So this is just a quick reminder what's Indigo and how the Indigo bus works. It's a communication bus actually, and all the devices present themselves on the bus. They say to all the devices on the bus what they can do. For example, when a client connects to the bus, it can ask who is on the bus, and every device will explain what are its capabilities. For example, we have a camera here, we have a filter wheel, we have a focuser, and the thing is that we have something additional called agent. Agents are something like a higher level drivers which contain some business logic, and the drivers themselves are really simple. They can only do exposures. For example, the camera, you can change the resolution, you can do exposure, you can set different things to the camera, but it's pretty much everything it can do. On the other hand, the filter wheels can change the filter, and it can be asked what's the current filter, and this is pretty much everything. And if you want some logic, if you want something to be done with these devices, the agents are responsible for choreographing the whole thing, and the client only instructs the agent what it wants to be done. For example, here this is the client says, I want to use the camera, I want to use the focuser, and I want to take 5 exposures of 30 seconds each, and then in red filter, and then take 15 exposures of 90 seconds each in the blue filter. It tells that to the agent, and agent does everything for the client. Client can now go off and let the agent do all the stuff. So it's a headless communication. It's the client doesn't need to be online for the whole thing, for the whole session. And then the client goes off, and the agent here starts to do everything. And at some point, the client can connect and ask about the status, what happened, and if it's ready already, and if the images are ready, it can download them, or it can download the images that are ready and wait for the others. It's up to the client what it has to do. So this is basically how Indigo operates. And the architecture is the following. We have the Indigo framework, which has the devices depicted here in yellow, and we have device drivers for each device, and we have agents. We have, for example, Alpaca agent, which can communicate with not Indi, but with ASCOM devices. So Indigo can disguise itself as Alpaca, and ASCOM can communicate directly with Indigo devices through this agent. We have mount agent, which controls, for example, the mount, the rotator, the dome, and can work with these devices. We have Imager agent, which controls the camera, focuser, and some other devices, and these agents can communicate between each other, while the device drivers cannot. They just only communicate between the agent and the hardware. And on top of that, we have some protocol adapters like Alpaca adapter, XML, JSON, LX20, and HTTP. For example, this is for the client communication. And this is pretty much everything about the Indigo architecture. I told you it was going to be quick. If somebody doesn't understand anything, he can go to the previous show. I hope it's still online and see everything in more detail. So Indigo drivers are three types of drivers. There are dynamic drivers, static drivers, and executable drivers. Dynamic drivers are really fast to communicate, and you can load them and unload them at any time. Static drivers are pretty much the same, but with the difference that they cannot be unloaded. They can be linked monolithically in your application, and you can use them just like part of the application. You don't need a server for that. You don't need anything. You just link the driver. And executable drivers are old style drivers. These drivers are done this way because we want to maintain some compatibility with Indy, on which we use the protocol for Indy. So we decided that we can use Indy drivers in Indigo, for example. And this is the only way Indy works. But this communication is a margin of an order of magnitude slower. So we don't recommend using these things. So I already explained what's the difference between agents and drivers. So I'm going to skip this part. And Indigo device classes, we have mount, camera, guider, focuser, filter wheel, dome, GPS, adaptive optics, field rotators, and some auxiliary devices like joystick to control the mount. It's a regular joystick like you use in the computer games. You can just plug it and use it. We support shutter. We had support power boxes, sky quality meters, dust caps, light boxes, weather stations, and GPIO. GPIO is general purpose input outputs. So these are some pins on, for example, Raspberry Pi, which you can connect to some devices and you can power on and off them like something like a power box, but you need some additional hardware to make it work. So agents, we have a lot of agents. We have Imager agent, guider agent. The guider agent is responsible for guiding. Imager is responsible for taking the exposures, for focusing and things like that. Mount agent is responsible for controlling the mount and the rotators and the dome, actually. Scripting agent is something that is very powerful, and I don't think any other system has anything similar to that. We use ECMAScript or JavaScript to write our own scripts and we can automate pretty much everything using this agent. And I'll show an example of that because the advanced sequencing is done using this agent, and everything is written in ECMAScript. We have astrometry agent and ASTAP agent. These are the agents which use internally astrometry.net or ASTAP for image solving. Unfortunately, ASTAP is not actively developed for some political reasons. I don't know why exactly, but anyway. So we have auxiliary agent, which connects to all auxiliary devices like weather stations, like dust caps, like power boxes, and controls those devices. We have configuration agents. Where we can store profiles. So we can not shut down, but we can save the current state of all the devices, and we can resume the same configuration later, which devices are connected to the telescope and stuff like this. And we can just save the configuration, and we can start with the same profile next time, or we can choose different profile and start next time with a different profile, which is useful if you have several setups which should be controlled by the same server. We have Snoop agent, which is obsolete, and I'm not going to waste time on it. And we had LX200 agent. which was supposed to mimic LX200 protocol. For example, Sky Safari uses LX200 protocol to communicate with the mount, but we obsoleted this agent as we moved its functionality to the mount agent. So we have the same functionality, but it's in the mount agent now. And we have Indigo server. Indigo server is provides network access to the devices, provides access control to the devices, which means that you can specify which user which devices can be controlled by which user. Every user has its token. I want to mention here that it's not a security feature. It's more or less don't interfere features. For example, if you have multiple telescopes on the network, you can give access to somebody to control this particular setup, but he cannot use the other setup. So it's not a security feature; it's just a safety feature. This was requested by the guys from the Colorado Observatory in Spain, because they're using Indigo, as far as I know, on their 80-inch Schmidt telescope. Indigo server can connect to other servers, other Indigo servers, and re-export their devices. Something like daisy chaining. You can combine several communication buses on one device, so you can control multiple. For example, you can connect your camera to one computer and your mount to other computer, and both computers can talk to each other, and you can control the whole things from the single point. So it provides service discovery. This is a protocol like this is actually Bonjour. Probably you know of this protocol, in which the server explains what he can do to the client. So you can discover this service. You don't have to enter the host name and things like that over the local network. It obviously can load and unload drivers, and it can operate in headless mode. For example, as I explained, the client can connect, can instruct, or can upload the program for the night or for several nights, and it can disconnect and then let the server and the agents do their job, and you can connect later and just to check on the progress or to download the data. And the clients, I already explained what they do. The clients are dumb. So to say, they are not. They don't contain any business logic. They can only instruct the server what the client wants to be done, and that's it. And they can collect the data and they can monitor the progress. This is pretty much everything the clients do. And Indigo supports multi-platforms. It can run on Linux, on Apple, including iOS devices like iPhones and iPads. This is new since the last time. And Windows with certain limitation. The clients can run on Windows, but the upcoming version 3 will be able to run the server and the drivers on Windows platform, but on this I'll explain later. We also provide a free integrated operating system image for Raspberry Pi computers, which is called Indigo Sky, which runs Indigo with a decent web interface, and you can connect several of them to control your devices, and you can use one of them, whatever your preferences are. It's really convenient, and we have a lot of users using this platform. And this was about Indigo. So I'm going to explain what is new in the Indigo framework since the last time we've met. The first thing is focusing. we have a lot of new stuff in focusing. We have more accurate and efficient and robust U-curve algorithm. So we call it U-curve. Some people call it V-curve, but I think more accurate is U-curve because the way it's calculated and the way it's represented inside is more like U, like not parabola, but something very similar to parabola, but not. It's not V-shaped, definitely. It's more or less U-shaped. So we have a better algorithm which finds better focus and works somewhat faster, and it finds focus most of the times, even if you're not close to the focus as other platforms request. So you can start way off the focus and you can still get a good focus with this algorithm. We added multi-star focusing. We can now we can use several stars and several tens of stars, for example, to achieve the perfect focus, which mitigates the problems, like to some extent, like seeing problems and things like that. Some other new thing, one other new things in the focusing is a backlash overshoot strategy for more accurate focusing. Now you don't have to measure precisely your backlash. You just need to know some approximate value for this, and you can add some overshoot factor like 2, and it's a multiplier actually. So if you have, for example, backlash somewhere around 50 steps, you can add overshooting factor of 2, and every time it will make some extra movements, and it will compensate the backlash on one side always. So this way you will be exactly in same position every time the focuser stops moving. This is very good, and it provides excellent results. In the focusing, this is not something really new. I mean, some other software has it, like Nina, for example. And we have also added new experimental feature, which is Bakhtinov mask focusing estimator, which actually uses the Bakhtinov spikes to assess the quality of the focus. It's still experimental, and unfortunately it works only for bright stars or for really long exposures, for a reason that when you put a Bakhtinov mask in front of the lens, the brightness lowers dramatically, and this is something we are trying to avoid and to make it work with fainter stars, but currently it works for bright stars only. This is why this feature is still in experimental phase. Next thing is dithering. We added different dithering strategies. Actually, 3 of them. Random, which was used up to this point. We added spiral, and we added randomized spiral. So why do we need different strategies for this? For example, if you have a read noise, it can be cleared, and it can be distributed with a random pretty good. It will be cleared pretty good with a random dithering. But for example, if you want to drizzle, it's much better to use something like more predictable way of movement. This will give you a lot better results in terms of upscaling resolution. Then you need the spiral, and the spiral is particularly good if you have some artifacts like streaking or bending of the image. This cannot be. It can be actually introduced by the random dithering, and it can be to a huge extent eliminated by the spiral approach. And at the end, we have a randomized spiral which gets best of both worlds, so to say. It's a spiral, but each point is randomized. It's random within a couple of pixels. So it provides best of both worlds. So it's the default strategy. I think we made it the default strategy in Indigo right now, and it gives a lot better results. So what's new on the Linux side only? Well, after a lot of user requests, I did something which is not yet released. So this is the first time appearance to the public. This is a Indigo server controller or Indigo server manager. This is a graphical user interface to stop and to start and to stop Indigo server and to save the logs and to monitor what's going on the server side. I'll show you this program in a while in the demonstration. And we have a lot of other features which deserve some mentioning. We have made, we have made automatic meridian flip, which is fully synchronized with the capture, so the flip will not happen in the middle of exposure. It'll if the time to the flip is less than the exposure, it will just wait. It will not start the next exposure. It will wait, and it will make the flip, and then it will resume with the sequence that you have requested. And it has two modes. One is just the flip, just flipping the mount, and the other one is plate solving assisted flip, which is it will flip. It will actually it will get the coordinates of the frame. It will make the flip, and it will use the solver agent to recenter the same exact frame. Now we have field derotation support for alt azimuth mounts. Obviously, you need a rotator for this feature, but now you can just use your alt azimuth mount for imaging, and it will automatically compensate for the field rotation. We have filter offsets for focus compensation for each filter now. I think everybody knows what's this about. If you change the filter, it will apply certain offset in the focusing, which you have entered. And this way, you will not waste time to refocus for each filter, because the differences are measurable. You can measure them and you can use them, so they're constant. We also added include and exclude regions for focusing and guiding. So, for example, you can define some areas of the screen where you don't want to have to use the guiding stars, or you don't want to use the stars for the focusing. For example, if you have a really curved field and you want to focus on the center of the screen, you can exclude the periphery of the image and some other things like that. Or you can exclude the center of the image for some reason. You can do whatever you want with this feature. We also defined strategies how to proceed when the stars are lost during focusing or guiding. You can choose one of these, like fail. It will just fail and not do anything. If you can wait for the same stars to reappear before it resumes, or you can try to find new stars on the frame and then continue. All these features are quite useful for different purposes. If, for example, clouds are passing, it may be worth to try to find different stars and to continue, just because you might need to wait longer if you want to other stars to reappear. Well, no, but yeah, you have it there if you want it. We rewrote all the agents. We refactored them for efficiency and for robustness, and we fixed a lot of bugs during this time. So the system is now a lot better than before. And also we have new hardware support. Pretty much all the new hardware that appeared during these 2 years, we have drivers for them. We added driver for ZW stuff like camera angle adjuster, like their mounts. Actually, I use them a lot. We added for the TAIC focuser, for the QHY focuser, for the Astro focuser and filter wheel. We added support for Wonder Astro stuff, like their power boxes, like their dust caps, light panels, and their rotators. So a bunch of new drivers there. So I think we support pretty much all the major, and not only the major, vendors of hardware. And what's new in the advanced sequencer? Actually, this is the part where I'm going to concentrate the most during the demonstration. It's the advanced sequencer. We implemented it in ECMAScript, in the scripting agent, and we have a lot of stuff which can be done with this. You can even load and unload drivers from the script. From the sequence, you can select an device to be used in this sequence. We added multi-target support, which means you can change targets in the same sequence. We have execution flow control. We have loops. We have recovery strategies and delayed execution. For example, with the recovery strategies, you can say, if at some point something in this sequence fails, I want to go to this part of the to some certain part of the sequence and continue from there. And we have delayed execution. Like we can say, I want this night to observe, for example, Rosetta Nebula. And when you finish, I want to park the mount. I want to turn the camera off and all the devices off. And you will wait till the next night. And next day, sometime, let's say 8 o'clock, you start imaging something different. For example, Seagull Nebula or something like that. So pretty much everything can be automated with the sequencer, and a lot of more I will show you in the demonstration in a couple of minutes. So what's new in Ain Indigo image? Indigo is a client. Ain is a client for Indigo that runs on Linux and Windows. And the first thing is something major since last time is that we support rotators in Ain. Here in this, you can choose which rotator to use. You can set the angle for framing, or you can use the auto derotation. And it will derotate, if you have an alt azimuth mount, it will derotate the field for you, and you can make long exposures with with alt azimuth mount. And the next thing, the big thing for Ain, which is available in version 2.0, is the sequencing. So here you can see some sequence which is executed, and I will demonstrate it in a bit. And part 4, What's new for the Apple ecosystem? Well, we have a full support for Indigo on all platforms. You can we have A1 Indigo A1 or all-in-one application for iPhone. For you can see it here, the imaging screen. You can have it on iPad on the right. You can have the guiding also. I'm showing you the screenshot of the guiding on how it looks on the iPhone and how it looks on the iPad. And I need to mention everything happens on the server. These are clients only. You don't have any devices connected directly to your iPhone or to your iPad. Something like Acier or Stella Vita, I think was called, from TubeTech, but it's something that we developed for ourselves, and it runs on Indigo. And it can be actually an usual PC, probably mini PC or full-blown computer or whatever it is. So it's Indigo server on the other side. And of course, it can run on macOS, but this is not something new. This was there last time. So, and this is what we have, and now I'm going to tell you a couple of words on what we are working. So what's upcoming on Indigo 3 Nulla? This is the big news. Probably half a year ago, we started working on Windows, full Windows support for the Indigo infrastructure. We are migrating drivers, agents, and the Indigo server itself to be able to work natively on Windows, so you don't have to use Linux or Mac OS for the server part. So you can run clients and the server and the drivers on Windows. The other big feature of Indigo 3 Nulla will be auto-generated drivers from a template. While we developed Indigo, we figured out that from 60 to 80% of the driver code is a boilerplate, which repeats in each driver category. For example, CCD cameras share something like 60 to 80% of their code, and only the device-specific stuff is changed. And this brought us to the idea that we can make a template for that. We can make a code generator, and we wrote a code generator that will generate from a template. You just say this is a driver for the CCD camera, and I want this thing to be done when you start exposure, and I want this thing to be done when you stop exposure and when you download exposure and things like that. So we just have some we write this code, and we run the auto generator, and it will generate the full-blown driver for us. And this is beneficial because if we have some copy-paste errors, like usually when we started new driver, we get an old one. We replace the camera specific start part in these drivers, and this way we propagate some old errors into the new drivers, and it's prone to copy paste errors. You need to change some parts, and we forget to do this, or we copy wrong part in the wrong place, and using this gives us a lot more control over the things, because if we have some mistakes or some bugs in the common code, we can easily fix it, and we can regenerate all the drivers all at once. So really quick and easy driver fix, because we had some unfortunate events when we have some same mistake in, say, 10 drivers or more, and it's a pain to patch every driver by hand. So Another big feature is bidirectional communication for multi-server setups. So when we have when we have several devices connected to one server and several devices connected to other server, now we can use I mean, one of the servers can combine the communication bus for each server, but the other servers cannot see the devices exported from the collecting server. And now we are making all the servers to be equal. So each one of them has everything. So you can connect to whichever you want, and you can control the devices from there. We are implementing more efficient client-to-server communication also. For example, when you request property enumeration at this point, the property enumeration, I mean, the capabilities of the devices are sent to each and every client on the bus. And in version 3.0, you will have them sent only to the requester. So you don't have to flood all the clients with the same information that they already have. And finally, we are working on a scheduler with all the necessary features like observing blocks. You can define a block for observing some objects. It can automatically select targets based on different criteria like best visibility. Some targets may have higher priority and things like that. And yeah, so this is what we are working on, and probably it will take something like 6 months to a year to complete all these things. I can show you the status at this point. So thank you. This was the presentation, and now I'm going with the next part, which is the demonstration. Any questions?
There were a couple of questions, but
Okay.
you addressed them as you went along, which I kind of suspected you might. So I think you've answered all the questions that were posed.
Okay. Okay.
Wait a second, Dad. I don't know if you noticed that last one from Jerome.
Oh, you know what? I did not.
Okay. Well, go ahead. Go ahead.
Let's see. So Jerome asks, given all the trouble moving from one operating system to another, have you been able to use any AI systems to help with recoding your boilerplate template?
Well, we attempted, and what we figured out is that AI is really good at pointing you in the right direction. For example, what calls and what what system calls can be replaced and how they can be replaced. For example, from POSIX, which is Unix, and it works on macOS and Linux, to Windows. But with the writing this thing, well, we have unacceptable results, let's say. So it tends to hallucinate, it tends to invent some features and some bugs that were not there. So we are really careful with using AI still, but it's getting there. Yeah.
Makes sense. Thank you. Looks like that's it for the questions for now.
Yeah. Okay. So now I'm going to show you. I'm going to show you, I think, the status, migration status for Windows and to the code generator. So I'm just going to run through it really fast. So you can see these green ticks are these drivers with the green ticks are migrated here to Windows. Actually, we have. Not all of them, but majority of them migrated to Windows, so everything almost works on Windows. We have a few drivers which are auto-generated already, which is the second column. a lot of drivers are still not migrated, but we are working on that because we need to rewrite some parts of the driver so that they can comply to this common code and things like that. So this is something we're working on. And this is the part that is retested with the version 3.0. So as you can see, it's still a lot of work to be done, but we are getting there slowly. So for half a year, we did all these things. I think in probably 1 year, we'll have everything migrated to Windows, and not migrated, but ported to Windows, and we will be able to regenerate all the drivers from this driver generator. And actually, we are working on reading the old drivers and making the template from the old drivers so that we can easily make them. So the old drivers, we are making templates from them so that we can generate the new drivers from this template in a bunch, like in a batch. Does this make sense? Did I explain it okay?
Yes, I think so.
Okay. Okay, so this is for what's new. So now I'm going to show you the sequencer of Indigo, how it can be used, and some tips and tricks on that part. Okay, so as I said, now we have a nice tool which you can use to start Indigo server. Here you can set the service name. It usually uses the host name of the machine. Here it's Vega. The port name, the log level, we will use info. And here you can enter the drivers manually and some other options. For example, you can get a server help here. All the options that you can write in this window here. This uses the Indigo server which is installed on the system. So this is only an UI for executing. And here you have a list. It sends query for each driver on startup and asks what are you doing, which device you can control, and things like that. So we built this menu here, and you can add and remove drivers from this menu here. For example, we can add GPS simulator, and there you go. We have GPS simulator here, and it will be loaded on startup. So we have some advanced features here which I'm not going to address. For example, enable and disable service discovery, so that if this server is going to be discoverable by the client, or you need to enter the IP address explicitly. And some things like blob compression, enable blob compression. If you're working over the network, it's a nice idea to enable blob compression. Blob is binary large object. For example, images are blobs, so you can compress images while transferring them over the network to save bandwidth and to make it fast, to make images delivered faster to you. And actually, you can use all these features, all these switches here. You can enter them here in this field, and you can enable and disable other features. But anyway, we are going to start the server now. Okay, the server is loaded. It says the server is started on vega.local on 7624 port, and we can just start our client now, which is Ain. There you go. And you can see we don't have any cameras selected, no filter wheels and nothing, so we can just select the camera here. You can select the filter wheel here, and you can just do a quick preview to see what. Well, this is the simulator. It always shows the Rosette Nebula. And you have the focus here. You can choose the focus strategy. You have a guider. You can choose the guider camera, the guider device, which can be the mount or the camera via ST4. You have the telescope here, which can be selected here. And all the things, the screen with the rotator that I showed you, site, GPS, you can do polar alignment from this top here. But I'm not going to waste time on this. I'm just straight going to the sequencer, and I'm going to show you how the sequencer works. So we're going to start with a simple sequence. We're going to start with a sequence like we want to set object name, like say, well, we have only Rosetta available here, so we should say Rosette. And this is going to be used as a file name, and this is going to be used as a file name it is going to be used in the file name, not as the file name, and it's going to be used as object in the image header, for example, in the feeds header or in the XSIF format, which is the PixInsight native format. We can produce directly PixInsight native format images. So we can do, for example, capture. We need to select a filter. For example, set the filter. Let's start with R filter, red filter, and you can capture batch, say 1 exposure, 60 seconds. It's too much for the demonstration. We will go for 5 seconds, for example, and then we can capture another. We can change the filter again to let's say green, and we want to capture 1 frame in green, again 5 seconds, and this is our sequence. So let's start it. Can go here, and it set the name, it set the filter, and now we are capturing the first image. Now we change the filter to green, and there we go. We have our first sequence finished, and we have 2 images produced. You can see them here: Rosette Light R and Light G. So this is really simple sequence, but we can go we can do more complicated stuff. For example, we want to loop this part here with selecting the filter and capture images, and we can do it this way. Go to the flow control, repeat, and now we have this repeat here, and we can drag all these things in the repeat, like this. And now we will have this section repeated once, or we can repeat it, for example, 3 times, or let's do it, for example, twice. And we can run it, and it will go to the and it will repeat this sequence, this part here 2 times. So here's the first one, and now it's doing the second one. Okay, so it's finished. So what if you want to, for example, go to bed, and we want to have our sequence started at a certain time? So we can just go here at the beginning, or we can, for example, go here and say flow control. No, not flow control, but wait until. Oh, it's in the wrong place, so we can move it at the beginning, and we can it puts the time, the current time, and we can just say like 2:25 UTC, and we can hit run, and now it waits, and it will wait, and it will not do anything until the clock until the time is 5:25. 5:25 in the morning, my time, and it's 2:25 UTC. So, okay, now it's continuing. It's doing its job. So I'm going to stop it. I'm not going to let it run. So this is about we can do something else. For example, we can put another thing here. We can say wait until, and we can program it for the next day, like yes, for the 13th. And at 2:25 13th, we can do something else here. We can, for example, capture batch, one exposure, 60 seconds, and that's it. So this will execute it on the next day, on the next night, actually. So I'm going to remove this. We are not going to waste time on this. So we can do some more complex stuff with this. For example, we can load our devices which we are going to use. For example, we can add them here at the beginning. We can add some devices here. We will select imaging camera. We will select, for example, mount devices. Where's the mount? We can select mount. We can select filter wheel. We need to select filter wheel. Yes, we have selected filter wheel. We can select guider, for example. Oops. What did I do? Oh, no, nothing. We can select guider. We can select guiding camera. Guider camera. And what else do we need? Probably nothing. So we can go and select from the available devices. We can select Imager simulator as the main imaging camera. We can select mount simulator for the mount. We can use GPS. You can use CCD imager simulator filter wheel that is attached to the imager camera. Guider, we should use, for example, this CCD guider camera simulator, and for the guiding camera we will use guider simulator. And now we have set up our equipment. We can even do things like this. For example, after we select the camera, we can do enable. We can do enable camera cooler, and we can set the temperature, and it will stay at this point until it reaches, for example, 0 degrees Celsius, and we can do -1 on whatever temperature we want. This wait until is okay, so we can put it here. It's something that should be or yeah, we can put it here, or we can put it here, so we can pre-set up our equipment and then wait, or we can wait before setting up our equipment, or you can put another wait for something like 20 minutes later or something like that. You can do whatever you want. It's up to you. So we have set up our equipment. So now now we have to make something like we want to go to our object. So we can do like mount. We can not use precise go to, we'll just slew there, and we can click here, and we can select our target, which is Rosette Nebula. Here it is, and we have the coordinates loaded. So we'll slew our telescopes to Rosette Nebula. We'll set our object name to Rosette, and we'll start our sequence then. And after that, we want to do something else. We want to shut down everything after we get our exposures, for example. And we can go to the devices. We can select filter wheel. Select filter wheel, yes. We can select devices. Select imaging camera. We can add some more devices. Basically, all the devices that we have set up, the mount, and then we can do guider camera, and when we have filter, select guider camera, mount, filter wheel, guider, and guider camera, select mount, imager camera, guider camera, and filter wheel. I think this is pretty much everything. and we will keep this no mount, no camera, and no wheel, and it will deselect them after we finish with the sequence. Oh, and maybe it's a good idea before we shut down our mount to park it. So we can go to the mount and say park mount, and there you go. So we can start this sequence here. And yeah, it will take quite a long time to set this temperature here, but you can see here it's working. It's 100%, and the temperature is going low. So we're not going to waste time and wait for this. I will just abort this and do and disable. Yeah, this is another feature of the sequencer. You can disable some items in the sequence so that they are not executed. For example, yeah, you can disable this thing here, and it will not set the camera cooler at all. So it will just skip this part. Yes. Well, with this wait until is in the past, so it just went through it like there's nothing. So and if we look at the telescope, okay, what happened here? Oh, it unparked the mount, and it's already there, and it started capturing. Yeah, started capturing. So now we're getting our images. We'll have this repeated twice. And now we're parking the mount. If we go here, we will see that the mount is going to its park position. And when the mount is parked, yeah, we had everything deselected. Yeah, no camera, no wheel. There's, oh, we we forgot to deselect the guider, the guider here in the sequence. So we are going to do, for example, like here, devices, and add select guider, and we'll use no guider. So yeah, that's it. But let's say, for example, we make some mistake, and because we can enter by hand, for example, guider camera, we can say guider camera 2, which is something that is not existing, and we run the sequence, and it failed. It says there is no CCD guider simulator 2 in the camera list. So, well, this is an error that can easily be caught, but for some reason, some equipment is malfunctioning, or for example, the clouds appear, things like that. You have some problem while executing the sequence, and you want to handle this situation. You can choose from several options how you can proceed. For example, I'm going to add here in the flow control is continue on failure. And now if we run this thing and we can select this guider camera, it will just come here. It will fail, but it will continue with the execution of the sequence as nothing happened here. Well, this is not really good for the sequence itself, but it's really good for this part here, that is shutting down the equipment. So I'm going to put this item right here, continue on failure, and I'm going to define here an recovery point, which means that if something fails during the execution of the script, it will go to the first recovery point that it sees, and this will be this one. And then I'm going to set here another strategy, flow control, which is continue on failure. Not continue on failure. I'm just going to remove both of these. It's wrong. It's continue on failure, abort on failure. Oh, should be like this. Let me see. It's 5 in the morning here. I cannot think too much. So let's see what will happen. No, it just failed. So we just a second here. Recover on failure. Yeah, this is the one that I was looking for. Recover on failure. And now if we execute the same thing, yeah, you see, it failed here and it went straight to the shutdown, to shutdowning the sequence, to shutdowning the devices, parking them out and things like that. Well, this is pretty much everything I wanted to show you. Well, as you can see, you can program your observations for several nights ahead with this feature here. Wait until you can drag and move all these things around. You can add them. You can add several repeats, whatever you want. You can do basically everything you want with this thing here. You can start guiding. Oh, and you can, for example, you can do like mount, enable meridian flip. You can enable meridian flip, and you can go. You can specify when to flip. If it's negative here, it will do it before the meridian, and if it's positive, it can do it after the meridian, and if it's 0, it will flip exactly on the meridian. And if you click this thing here, it will use solver to recenter the target when you flip. Yeah, this is pretty much everything I had for tonight. If you want to, if you have questions, or I'm open for discussion.
I have a couple of questions,
Yep.
Rumen, about the focusing, which you touched briefly but didn't put into your sequence there.
Oh yeah, you can do it. I can modify the sequence so that we can add the we can do the focusing. So what's the question?
Oh, I was just wondering how it works as far as, is it focusing like on the target where you are? Does it slew to a spot to focus?
It uses it can use multiple stars on the frame. You can it should be on the in the frame you're working, you're exposing. So it can work on really faint stars, so it's not a problem in 99.9% of the cases to just select to just say just focus. You can add whatever exposure you want for the focusing, for example, like 5 seconds, 1 second, or whatever you want, and it will do the focusing for you on the frame that is that you're currently trained the telescope. So if you want to focus on somewhere else, you can do it like slew somewhere, like here. Then go here and focuser and focus, and then with exposure, whatever it is, like 1.2 seconds, for example, and then you can go to the mount and then slew, and then you can choose your target. For example, let's say, well, here we can, let's say Rosette here. Rosette, it's not, it's Rose. Yeah, it's like this. And you can say here some bright stars, Betelgeuse, for example. No. There you go. And now you will focus on Betelgeuse and then go back to Rosette with this sequence.
I see. So by default, it'll just focus where the scope is pointing, but you could, like you said, set it up to go somewhere specific if you wanted to do it that way. So
exactly. And yeah, and you can do it even differently. You can do it, for example, with precise go to, which will you'll specify some exposure here, like 2 seconds, and we can choose Betelgeuse, and you'll use even plate solving for retargeting in this case, and we can just remove this thing here.
Is that the difference? Yeah, you had showed the slew options. One of them was just slew, and now you've got a precise. Is that the difference? Some uses plate solving, some is
Yeah.
just, you know,
Yeah, the
rougher.
precise go-to uses plate solving, and slew doesn't use plate solving. It just points the telescope there, and it assumes it's on the spot. This is useful for precise mounts, and for the consumer grade mounts, it's advised to use a precise go-to.
Sure. And then are there any notification settings? You talked about some of the options if there's a failure, but like, can you set it up to say send you an email if there was some kind of major problem?
Not yet, but we're going to implement this.
That's on the list, huh?
It's on the list, yes.
Sounds like a pretty long list. Still, even all the things you've done.
Well, it's never-ending journey, you know.
The more you do, the more you need to do, right?
The more features you add, the more you need.
Yeah,
well,
exactly.
the next on the list is well, we have some sort of notification, but these are server-side notifications which are sent as messages. And for example, you can add notifications to your iPhone, which is connected to your server, for example. It's not available for Android yet, but you can send your notifications to and all these things, all these notifications here, and all these errors here that are shown in red will go to your iPhone but in your application, and you can set your application to send you some alerts and things like that, but not to the email or to. So far, you can do it only on your phone as long as it's iPhone.
Sure.
Yeah.
Well, and there's been a number of comments just impressed with the number of features that you've been adding here. There was a question about, let's see, Rick had asked if you can run it on an x86 implementation of Kubuntu.
Yeah. You can run it on every Linux. You can run it on 86. You can run it on x64. You can run it on ARM32. You can run it on ARM64. You can run it on both ARM and Intel macOS. And in version 3.0, you'll be able to run it on Windows. And the primary development on this goes on ARM Windows. So you can run it even on ARM Windows. But with an exclamation here that very few manufacturers provides software development kits for their hardware for ARM Windows. So not all the drivers will work on ARM Windows.
I see. Well, and I guess similar to that, I imagine you mentioned you've got a Mac OS version and it runs on Apple Silicon or an Intel-based Mac. Either one is no issue. Is that right?
Yeah. Well, we have pretty much all devices covered for Apple Silicon, but there's a Rosetta there, and you can run it through Rosetta. If some driver for some reason doesn't work on Apple Silicon, you can run it in the emulated environment of x86. But we migrated, actually, for example, ZWO do not provide Apple Silicon SDK for any of their products. And I had a conversation with them, and they are building it especially for us. And I think we are the only ones that have this support for the camera angle adjuster, for the focusers, for the filter wheel, and for the cameras. And it runs pretty good. And I have no idea why they don't want to release it to the public, this SDK for the Apple Silicon, but it's their choice and their decision.
Interesting. Also, let's see, Jeff had asked, will Indigo work with the 10 micron mount?
Yes. I think we have a driver for this specific driver. Let me just show you. Oh, I have to stop the Indigo server here. but we don't need it anymore anyway. So I'll just stop the server here. Okay. And mounts. We have iOptron. Oh, 10 micron is LX200 driver. Yeah, it runs with LX200 mount.
Okay. Well, I think that is all the questions. Yeah, so well, this has been really interesting, Rumen, and really impressive. You know, I think it's been a little more than 2 years since you were on before, but
Yeah,
you guys
something
have
like
been
2 years. Yeah.
you guys have really been hard at work on this this application, and this is free software, right? You're not there's
Hello.
hello.
How, Roman, how does one get the software? Is it a simple
It's
download?
free. Yeah, it's free. You can go to our website and let me show you real quick. So I'm just going to yeah, this is our website, and you can go to downloads, and you can use for Linux, you can use our Debian repo. You can just add this line to your Indigo. You can actually execute this command on your command line, and then you can do upget update, and then you can install all the parts of the software with these commands, or you can use the graphical tools for that. And if you don't want to do this, you can just download individual packages from here. You have Indigo server for different platforms. You have Indigo control panel. I didn't show the control panel, but let me show you real quick. For example, I'll start the server again because we need it for this. So it's here. And here you have all the devices, all the things that you can control with your server. And you can just browse the properties of each device. For example, if we go here and we select, for example, we select here the camera imager simulator. Here you see it has this green dot here, which shows you that this device is connected already. And you can see all its properties, the supported modes. You can change the modes. You can change the gain. You can change gamma. You can change the upload mode. For example, if you're working offline, for example, if you want to run the sequence and everything to be saved on the server, you can choose these options: save on the server, or you can upload and save. Upload means that the image will be sent to the client and it will be saved on the server at the same time. So if you, for example, disconnect and then you reconnect to your client, you'll be able to get all the images that you missed during this time. So you can control everything from here, and you can control all these things from the sequence itself also. And yeah, so you can just download the software from the repo, or download the software from our web page. Here it's how to install it on macOS, just drag and drop, nothing really fancy. And yeah, so you can go to our website, and there are links for everything. Unfortunately, Peter decided, well, I know it's unfortunately, but Peter decided that he will charge for the Mac and iOS and iPad versions of the software, something like 15 euro or something like that, which is something like $15 or something like that. It's a single time purchase, no something, so it's pretty cheap. But the Linux and Windows part and the server itself are completely free. They're even open source, and for example, you can just get the source code from our repo on GitHub. So there you go. This is the complete source code. You can just get the code. Just get this link here and clone the software. And if you know how to build it, you can build it yourself.
All right, well, that's great. And, at the opening of the show, I had mentioned that Indigo was doing similar function as ASCOM, but that's really just scratching the surface with all these extra features you've put in. I mean, this has really become full-featured acquisition software with everything you've demonstrated here tonight. So
yeah, the idea is that Indigo is that Indigo is the framework. It's not drivers, or it's not something that it's full in itself. So Indigo server with the agents actually contains all the business logic, and this part here, this client here, this is only the visualization. This is only the things that to present to the user in a good way. It's not necessary to run the things. I can, for example, I can show you what I mean. Is the server running? Yeah, it's running, and we have, for example, here we have Imager simulator, and we'll take, for example, let's say infinite number of 5-second exposures, and we'll start exposure, and it starts exposing 5-second exposures. So we'll get the first one. Oh, we didn't provide object name anyway. So let me just remote images, save remote copies on the server. Yeah, it's configured correctly. And we can come back here and say, for example, images. Yeah, rosette. I'll just put rows. This is pretty much all we need. Expose, and it will start exposures. And now we can just close the client. We get one frame, and we're closing the client. There you go. We close the client. The client doesn't know what happens, so we'll close even this one here. And in something like 10 to 15 seconds, we'll reconnect. We'll open the client. Well, I hope we have several images already, so we'll have a new one here. Okay. So I'm hitting abort. So let's see what we have here. Go to remote images, download images. Wow. We have several images that we missed during the time that we didn't have the client connected. Okay. Hello?
yeah.
Okay.
All right.
All right. Any other questions?
I don't think so. Wait. I do think there is another question. Can you recommend for the RPI users out there? Oh, no, I'm sorry. That's not a question. It's a recommendation.
Okay.
All right. Yeah, I think we got everything. So
Sounds like it works on Raspberry Pi, which is very cool. And I think a lot
Yeah,
of
it does. It
people would
does.
be excited about that.
Yeah, I have it here actually. I have my Raspberry Pi here. I have to disconnect it because the cables are not very long, but do you see
Excellent. Yeah. Fantastic.
it? Yeah. So I'm using this one for development. It's Pi 5, but it runs fine on Pi 4 and even Pi 3. We are testing it on each of these.
Do you guys have like a Discord server or a forum, a place to discuss issues?
Yes,
problems?
we have. It's if you go to our website and you can scroll all the way down, it's right here.
Okay, sweet. Awesome.
all right.
Don't forget you can stay on with us, Rumen, after we hang up the YouTube call.
Yeah, okay.
If you want to chit chat, or you can go to bed.
Yeah,
Or go to work or whatever you have to do at
I can stay for
6
a while.
a.m. now, right?
Yeah, 6 a.m. I'm going to bed afterwards and waking up at 8.
Okay.
Okay. So,
Well,
yeah.
we really appreciate you getting up at 3 in the morning to do this at 4 in the morning and stay with us here and present all of this really interesting information and this this has come a long way, and it seems like it's just going to continue to get better and better. So maybe in another couple of years, you can come back and show us another hour's worth of all kinds of new features that you guys have done.
Yeah, well, we have a lot of things that are working that we're working on. So when we come to the version 3.0, I think there will be a lot of things, a lot of new things to show.
All right, well, we'll look forward to it then.
Hopefully the sequencer will be not the sequencer, but the scheduler will be fully functional. Because now it's not really a scheduler, so you schedule everything by hand, but in the other version, it will be automatic.
Amazing.
That'll just be even that much better. So, all right, everybody. Well, we will see everyone next week. And with that, Molly, you can take us out.
All righty. Good night, everybody.
Good night.
Bye, everybody.
Have a good night, you all.